What a fascinating discussion on so many of the wonderful technical elements of increasing solar and storage, integrated resource planning, making sure that we account for how solar and storage is going to impact both the distribution and the transmission grid. Thank you to that wonderful panel. We're going to take a similar technical approach, but a slightly different example of this as we look at microgrids next. And I'm so thrilled to bring Scott Hinson, who's the Chief Technology Officer for Pecan Street up in Austin, as he's going to talk about their work around microgrids. Thanks, Scott.
Thank you so much. Thank you. So I'm going to start off with a story. Who here watched Saturday morning cartoons? Come on, be honest. Be honest. This was important stuff when we were kids, right? The reason I'm telling the story is it kind of gives a little bit of insight into my psyche, which is a scary place to be. Saturday morning cartoons represented a problem for me because if I slept too long, I didn't get to watch the shows that I wanted to, all right? If I got up early enough, I could see Looney Tunes. If I slept a little too long, I was forced to be happy with just Tom and Jerry, and if I slept way too long, I had to watch the Smurfs. And now I just made everybody think of the theme song, so job well done. So none of those were my favorite. The problem is that the best cartoon was stupid early in the morning. So when my dad got a new alarm clock, I took his old school one with the bells that he hated, and I set it for something absurd. So I was watching like infomercials before it started. And I sat there with a gigantic bowl of sugary cereal, pounded down probably half the box, so that I could watch the hour before all those other cartoons started, which typically included Speed Racer, Mighty Mouse, or my favorite, Rocky and Bullwinkle, okay? So I had solved my problem. My dad thought it was a different problem because now he's from hearing this alarm clock go off on the one day he can sleep in, right? And he finds me watching these cartoons, and he's like, all right, I'm going to sit down with you. And I enjoyed Rocky and Bullwinkle so much because they always had alternate titles. Things like Rocky's Dilemma or Squirrel in a Stew. So I've got this title up here, the role of solar and storage in microgrids, but the or is do as I say, not as I do, okay? Pecan Street got a grant a few years back to do a residential microgrid, and we sold this proposal to the DOE on the concept that we would have more energy inputs than you typically see. The real reason that we wanted to do the project was because of issues that I saw at the interface to the house when you started to add solar to it, okay? For years, I had done power factor correction for industrial purposes. I worked for Royal Dutch Petroleum for a while. I did some power factor correction for hospitals, and these were very large facilities that were getting penalized in Shell's case, something on the order of about $50,000 a month for a single facility. So very quickly, power factor correction kind of pencils out for these facilities. And when we started to look at the data that we were collecting on houses, which is Pecan Street's normal sort of reason for existence. We're a nonprofit that collects all this data and then provides it to industry and researchers around the world. We've got like 2,000 academic researchers in 70 countries from 170 institutions accessing the data. We collect about 4.5 billion, with a B, data points a day on how people are using and producing energy. When we started really digging into that data, and we were putting power quality meters on houses, I was horrified by what I saw, okay? Now, I've heard a lot of talks here in the last couple of days about sort of intermittency and arbitrage and all these sort of bigger picture applications for energy storage and solar combined. But what I haven't heard is what happens when you really start to shrink the grid. You know, we keep talking about microgrids, and for our scale, these microgrids are massive, right? When I'm talking a single house, we don't have the benefit of sort of the getting a slower moving load from a variety of load sources there. So when I started looking at these houses, I was horrified by what I saw. For the distribution folks in the room, they may, if they haven't seen these numbers, are probably going to be fairly horrified too. I would see houses average a power factor for a day of 0.3. Okay, I would see houses with average harmonic distortion for the current at 200%. Okay, and this got started because we had a group come to us, CSET, which had Centerpoint asking them some questions. They had a feeder where the majority load on that feeder is a residential community where there's some mandated solar. So every single house had solar, and they were seeing a power factor at the feeder during the shoulder months of 0.6 and very high harmonic distortion, which was causing the low power factor. And they thought it was that the solar was putting the distortion on the grid, and that's not the case. Okay? That distortion, all those harmonics were already there. They're being exacerbated by energy efficiency programs, and yay, energy efficiency programs. Don't go away saying that Pecan Street says that energy efficiency programs are bad, right? They're great. But all of those variable speed drives, all of those compact fluorescent and LED light bulbs with switch mode power supplies are contributing to this problem. And whereas you used to have the ability to sort of randomize your harmonics because motors would arc at different spots in their rotation and stuff like that, they're all running off the same few chipsets for control. So now all of your harmonics are in sync, in phase, and amplitude, right? So they start to add up on each other. So we said, all right, we're going to do an energy storage program where not only do we make a device where it takes care of sort of that standard energy arbitrage or no sell back to the utility, we're going to have it do other things. And we partnered up with a commercial entity in Austin called Concurrent Design. And we developed these, what we called the energy switch. And what it did was solve all of the problems that I just talked about, but it also did the standard stuff that you'd want it to do. So it had 5 modes of operation, okay? First, it would emphasize local consumption. Second mode of operation, it would sell back to the utility. It would emphasize solar production sell. Third mode of operation, it would take the structure off grid. Fourth mode of operation is it would take the structure off grid and accept energy from a backup source such as a diesel or gas generator. Fifth mode of operation was a maintenance mode or an overload mode where the system would trip itself out and put the house back on the grid so the house would operate as normal, okay? Now, in all of the talks that I've heard so far, I've heard relatively little about the needs of the consumer from the consumer's perspective. It's what everybody is thinking that the consumer needs, right? So this system would take you off grid and run your house as backup power, okay? Yesterday we heard somebody talk about, and they started to put dollar values to this backup power application. I don't even remotely go there, okay? Backup power is a consumer choice. It's a consumer purchase. There are 2 questions that consumers ask themselves before they buy something. Do I want it, and do I think I can afford it? Okay? And if you answer yes to both of those questions, whether or not you can actually afford it almost doesn't matter, right? You're probably going to buy it, okay? So there are millions of gas generators in this country. They don't pencil out, just as was mentioned yesterday, but people want them. My parents went through Hurricane Ike. They then retired and moved to Austin. They live in West Austin, and they have a 20 kilowatt backup generator, okay? It has never been used for backup power, all right? But that experience for them was so bad, my dad wanted it, and he decided he could afford it, and he could, so he just had it built in with the house, right? So the energy switch would do all these modes of operation. And when I went to describe these modes of operation to the homeowners, because we built them, we made 4 of them. We put 2 in houses for 2 months. When I went to describe these 5 modes of operation, I got a lot of blank stares, okay? And in fact, the second install was a home where I can only aspire to have a garage as neat as this gentleman. His 10-year-old son was standing there, and he's listening far more intently than Dad is, because Dad's looking at this big box with batteries and fans and inverters and stuff. He's like, what did I agree to? And finally the kid says to me, so if the power goes out, I can still play my Xbox? Yes. Yes, kid, you can. Because he's eyeing this thing like, you're taking up my remote control car space here, dude. And he's like, cool. And he goes off. And he was sold at that point. So the lesson that we learned from just that one sort of installation introduction was these things need to be 100% automated. Those 5 modes of operation were 4 modes too many, okay? It needs to go into the house and take care of all of those problems, and the homeowner should not have to think about it, okay? Now, it did back up power, right? And in fact, when we demonstrated it to an engineer that came down to validate performance for the federal government from NREL, I threw the main breaker for the house. We went into the garage so that I could show him the operation. He was charging his laptop off of the power from one of the outlets from the garage. He did not notice that I had thrown the main breaker, okay? There was no light flicker, nothing. The house just kept on running. We went inside to get some drinks. The homeowner came out and said, it's hot out here, come on inside. Let me get you some ice water. We walked inside. We were talking for a good 20, 30 minutes. And then he says, all right, so let's try off-grid mode. And I was like, we are, right? And nothing has changed. He's like, oh, wow, oh, okay. It normally only took me 20, 30 minutes in total if the weather was cooperating to demonstrate all the modes of operation. But he tested that thing for several days, right? And at the end, he's like, yeah, it does this. All the modes you talked about, but it also does these benefits where in a world where every house has solar, those issues that we saw at those initial measurements start to propagate back up farther into the systems, right? So it does full-time power factor correction. That house was always at a power factor of 1 or -1, so it was always a perfect resistive load. Not only that, but I had the NREL engineer pointed out a benefit that I had never even considered. It wasn't even on my roadmap. But when you go into a house, when electricians go into the house, they pull a bunch of wires into your panel. They start terminating those wires into your circuit breakers. They make a great game of labeling all your breakers wrong. And then what ends up happening invariably is that your phases, your 2 phases for line 1, line 2, are unbalanced. Well, not only did we correct power factor, we had a perfectly balanced load at all times, okay? The other thing that we could do is, and this was not even a mode that we told the homeowners about, because if they couldn't handle the 5 that we had, this was an operating procedure that they just weren't going to understand. In that either of the grid interactive modes, if you were trying to maintain your solar production and use that locally, or if you were trying to help out the grid by selling, I could set caps, okay? I could set load caps or generation caps. And so if you look at a residential structure with solar, its crest factor, its sort of average or minimum to maximum load can be 9-to-1 or 10-to-1. So I could set to a much narrower range. And now all of a sudden this becomes a congestion management tool, right? So I could say at most you're ever going to sell back 1 kilowatt. At most you're ever going to be a load of 3 kilowatts. You figure it out. And the battery got pretty good at figuring it out, right? So we had some pretty interesting performance there. Lastly, one of the things that we learned is that when we did this project, right, the technology wasn't quite ready, all right? The very first day that we had the system installed, we went to operate it in off-grid mode. It was operating great for about 45 seconds, and then the lights went out. It's like, ooh, that was bad. So I pull up the error logs out of the system, don't see why, turn it back on, reset everything. It runs for another couple minutes, lights go out again. Great. This is a 12-month program. Because of various contracting issues with the federal government, I really only had 8 months with the team at Concurrent to get the thing into houses. And if you're designing something with a life safety application and implication to it, 8 months is not a lot of time, right? There were a lot of nights and weekends on that one. I've had that tattoo removed since then. The lights go out and we're wondering why. And this time, however, the internal data acquisition system caught something and it said overcurrent protection. What's causing that? Well, we went back and we started looking at the data that we had collected, because remember at the time we were Pecan Street was collecting, we've been collecting data for 10 years on these houses, right? We have the world's largest residential energy usage database, right? And we have all this data, but it was at 1 minute interval. And what we had found was a house, we put these things in 2 houses, they both had equal tonnage air conditioning units, but the one was older and its start-run cap was starting to fail, and the inrush current to start that air conditioner was 150 amps for 3 cycles. Okay, that's going to kill almost any synthetic inverter that you're going to put on there, right? At the time, they were starting to make announcements for Tesla Powerwall Model 1s, and I'm looking at these 2.5 kilowatt battery backups. I'm like, that's not going to get an air conditioner going. You need 3 of them, right? This was a 10 kilowatt hour, 10 kilowatt peak system, and it still couldn't handle that inrush. So we had to go back and retrofit folks' homes to handle these systems. These are a whole bunch of systemic changes that I'm talking about that the homeowner should not, does not, must not be aware of if we're going to get this stuff adopted. Okay. Let's see, what else? I think, and because I know I'm standing between lunch, I'd like to take some. You've got one more after you. Oh, I do. I'm not. Okay. Do we have time for some questions? I see I still have. Okay. I think I'm going to open it up to questions here at this point. If anybody has a question for me on this system, or what Pecan Street does.
Mike Sloan, Verse Energy. This is real quick. If you can elaborate on that last point, you decided to make the system more robust, but it seemed like they've got a real problem. If they've got 150 amp coming in and start the AC, they need to fix that. And
we did fix that. And what I ended up having to do was I found solid state soft starts for air conditioners, and I forget the company that made it. I think they've since gotten bought out by Schneider, because Schneider buys a lot of companies, right? And that reduced that inrush current to about, I think it was like 10% over the nominal run current for the device. I liked it so much, I just got it for my house so I could stop the light flickering.
Project with the current design, build 4 or 5 of them. What's the status of that? Is that just simply a prototype and it's on the shelf?
Yeah, I guess that's another takeaway from this thing.
The reason I was asking, I've been wanting to start a company to build
something like this. Again, this is goes back to the do as I say, not as I do. The way we did it with 95% off-the-shelf components, I had to make some custom hardware for supervisory data acquisition. The system made about 300 decisions a minute in terms of do I need to do something to protect myself? Then there was even inside of that control loop, there was stuff that would just automatically shut down, not wait to tell anybody. Then we had to monitor, see why it shut down, and stuff like that. One of the big takeaways here is that the level of integration that you would need is going to require some pretty substantial investment. Okay, there are systems that are a lot closer at doing this. For instance, LG Electronics now has a battery and inverter combo that take DC solar or AC solar. It can grid form. It can ramp and control the AC solar like we did. It can do all these things, and it's a far more integrated package. It doesn't have the individual circuit load control like we did, because when we'd go into backup mode, we would shut off a quarter of the house. If we had a generator, we would shut up half the house if we didn't have it, right? So we had 24 circuits of load control. We had a whole bunch of other stuff. That system is probably as close to an energy switch that's an integrated system. But even then, it still falls short, like a lot of the smart inverters, in that the reactive power compensation that it can provide is displacement only, not distortion. So you still have this sort of elephant in the room sort of hanging out, and you haven't fixed that problem. So yeah, it's going to take a fair bit of money and a lot more integration to make it as easy to install as I'd like. The good news is that the batteries are substantially cheaper, right? The batteries are getting cheaper and cheaper by the day, frankly. The very first batteries that we had, those things were about $60,000, right? And then the last set of batteries that we bought for the Austin Shines program, depending on where we were able to get them from, was between $4,500 and $6,500, and it was the exact same capacity.
With such a large data set and the complexity of all of these different components behind the meter in houses, have you started to look at, all right, what's the value of the unoptimized total system that data set represents to Austin Energy and for grid operators?
We have been starting to look at that probably for the better part of 7 years. The problem with that is that every time we sort of peel back more and more layers of the onion, the question starts to get more complicated. We've had several of our academic researchers that have access to the data have published some interesting research on this, and I even think they're only scratching the surface. And they spent, like, I have many projects that I'm working on. I don't have a year to dedicate to that and get a real good number. They have, and I still don't think that they've gotten that great of a number. It's just better than what I can come up with. I can point you to some of those papers. Come find me afterwards, and I'll give you some contact information and show you where to look. Everybody go to our website. Even if you don't qualify for the free academic access, you can see sort of how you could get access. There are commercial licenses available. And then we also have a link to research papers that have, they're supposed to talk to us and say, we're publishing this research paper, so I can't guarantee that all of them I agree with. I've seen some doozies out there, but we do, for as many as we can, we put the links up to those research papers so you can get to them.
What's that website?
pecanstreet.org.
Thanks, Scott.
Thank you so much. Thank you.